This is another experiment, and the name of this experiment is determination of relative density of soil. So relative density is sometimes used in equational soils to describe the degree of density, like how much it denses the soil or how much it loses. So we have to take the natural condition, maximum condition, and the minimum condition. So here in your experiment sheet you can find we are using the void ratios whenever we are taking the values, but in the lab or in the experiment to getting the void ratio is much difficult. So in that cases we are using the unit weight to get the relative density of the soil. So before starting the experiment we are providing some equipments and the materials, and we are giving some lists here, like first of all you can see a balancing machine where you can get the weight, and now you can see the beaker or the mold where you can input or you can pour the materials in the mold, and the height of the mold is 150 millimeter. Simultaneously the diameter of the mold is also 150 millimeter. So whenever we are pouring, we have to temper the soil sample. So in that cases we are using the rod or tamping rod. This is called as tamping rod, and this is 16 millimeter diameter, 600 millimeter in length. So now we are getting the we are having a straight edge. You can see the straight edge is here, and you can see the scoop is here. This is straight edge and this is scoop. This is hair brush. You can see the hair brush where you can clean the surface of the mold, and this is a funnel by which we can pour the soil sample, and this is the desired soil sample. And by using the oven you can find out the dry sample, and this is the oven. You can see the oven here, and by using the oven you can find the dry sample. Now let's start the experiment. Before starting of the experiment, we have to take weight of the mold. So we are taking the mold to the balancing machine, and the balancing machine shows that the amount is 4,730 grams. That means 4.7 kg. The weight of the mold is 4.7 kg. Now we are using two steps here. The first step is for the loosest step, and the next step we are going to we will go for the densest step. So in the loosest step we are just pouring, and we are just taking the soil sample and using the funnel we pour the samples in the mold. You can see the pouring, and you have to fill the mold totally. No matter how much soil sample we are pouring, we are continuing the pouring process till the finishing or till the filling the mold. The process continues, and that is a continuing process. You can see. In the pouring process, the dust may produce, so you can find the necessary to prevent from the dust. You can see we are getting closer to filling up the mold, and we have to overfill the mold, because if you don't overfill, you cannot get the actual weight. So by using the straight edge, we can cutting the extra portion of the soil. Like you can see, clean the surface. So by using the hairbrush, we are cleaning the total surface, extra surface of the mold to get the desired result. And now we are getting the weight of the machine by using the balancing machine. You can see this is the amount is 8,670 grams. So if we are deducing the result from the previous only mold weight, we can find how much we pour the soil sample. So we are getting closer to the first step, and this is the loosest step. And now we are starting the densest step. And for the densest step, you have to clean the mold first. And in this process, we are not only pouring, but also we have to tempering the soil sample in 3 layers. And now we also need to take the weight of the mold, and this is 4,728, and it was also previously taken in the loosest step. So we are pouring some samples, and it's an assuming portion. Like you have to pour the mold by 3 layer, by 2 layer. So first of all, you have to by 3 layer. First of all, you have to pour the mold 1/3 of the mold. Pour the mold in the 1/3 of the weight, height of the mold. And now we are using the temper, and by doing 5 times, you have to form the temper from 2 G height. The first step is that, and in the next step, we are going up the 2/3 portion of the mold, and also repeating the temperature from 2 inch height. You can see the process. Whenever you are tempering, you should be careful with the surface. Now we are feeling the total mold, that means the total height with the soil sample, and we are continuing the tempering. We are almost close to the end of the process, and using the 25 times tempering. And now we are using the straight edge to clean the extra material which is on the mold. And by using the hairbrush, we are cleaning the surface of the mold. Finally, we get the mold filled with a dense soil sample. So whenever we are putting the mold in the weight balancing machine, the result shows that this is 9,146, that means 9.1 kg. So you can see the difference between the loosest and the densest in the weight portion. So whenever we are calculating all of these results, we can find out the our desired result, that means the relative density of the soil samples. Thank you.
Now we are going to describe the calculation for the determination of relative density of soil. In the theory, they are proposing that the void ratio is used to find out the relative density, but in the lab it is difficult to find out the void ratio. In that case, we are using unit weight. In unit weight, we are taking two types, like one is gamma d maximum, that means the maximum unit weight, and gamma d minimum, that means minimum unit weight. In our video, we also show that some of the experiment or first part of the experiment was for the loosest state, and the next part of the experiment was for the densest state. The loosest state gives the gamma d minimum, that means the minimum unit weight, and the densest state gives the maximum dry unit weight. So here they are giving some information like the relative density of a soil indicates how it would behave under loads. If the deposit is dense, it can take heavy loads with a very little settlement. The range of the value of relative density may vary from a minimum of 0 for very loose soil to a maximum of 100% for a very dense soil. So we are using the result of this experiment to get the discussion or to get the decision that is the soil in very loose condition or the soil is very dense condition. This is the experiment procedure and this is the calculation. In the calculation, the height of the mold is 150 millimeter and the diameter of the mold is 150 millimeter also. So by using the height and diameter, we can get the volume of the mold, that means the cylindrical volume. This is 2650 centimeter cube. Assuming the field density is 1.56 gram per cc. This is for the loose state. In the loose state, we found in our video that the weight of the mold was 4728 gram and the weight of the mold plus dry soil was 8670 gram. If we subtract from this value to this value, we can get the weight of dry soil, that means 3942 gram. Simultaneously, we can find the weight of the dry soil for the densest state and the value is 4418 gram. And if you are using the equation or to get the dry density or the unit weight, we have to divide the weight with the volume. So for the loosest state, the dry unit weight was 1.488 gram per cc, and for densest state, the dry unit weight was 1.667 gram per centimeter cube. So by using all of these values and the equations, we can find the relative density dr. You can see the relative density dr is 0.67. So this is the summary of the result. The average dry unit weight in the loosest state is 1.488 gram per cc. The average dry unit weight in the densest state is 1.667 gram per cc. The final relative density is 0.67 or 67%. So we can conclude that our sample soil tends to dense soil as it is closer to 100%. So this is the end of this experiment. Assalamu alaikum wa rahmatullah.